People have been capturing the energy in moving water for thousands of years, and today it is still a powerful resource that can generate clean, renewable, and affordable electricity. We harness energy from flowing water and convert it to electricity. That is what we call hydroelectric power or hydropower. Hydropower is the largest contributor of all renewable energy sources and accounts for 6.7% of worldwide electricity production. Further growth of this major technology may be possible, though many countries have already developed cost-effective sites. There are three main types of hydropower. First is impoundment facilities. Impoundment facilities are most common technology which uses a dam to create a large reservoir of water. Electricity is made when water passes through turbines in the dam. Second is pump storage facilities. Pump storage facilities are similar but have a second reservoir below the dam. Water can be pumped from the lower reservoir to the upper reservoir, storing energy for use at a later time. And the last one is run-off river facilities. It is rely more on natural water flow rates, diverting just a portion of river water through turbines, sometimes without the use of a dam or reservoirs. Since runs-off river hydro is subject to natural water variability, it is more intermittent than dam hydro. Hydropower is an abundant, low-cost source of power, and despite high upfront building costs, it is also flexible and reliable source of electricity compared to other renewable options, as it may be stored for use at a later time. Dam reservoirs can also help with flood control, be a reliable water supply, and may be used for recreational purposes. However, there are many concerns with hydropower, particularly large dam facilities. Damming a river has a significant impact on the regional ecosystem by flooding upstream landscapes, disrupting habitats for wildlife, blocking fish passages, and often displacing local communities. In addition, dam failures can be catastrophic, further disrupting landscape and claiming the life of those living downstream. Finally, hydro plants are not completely free of greenhouse gas emission, as with most forms of energy, carbon dioxide emissions occur during construction, particularly as a result of the large quantities of cement use and loss of vegetation in flooded areas creates methane, another greenhouse gas, as its matter decays underwater.
Basic construction of hydropower generation consists of a few main components: dam and reservoir. The dam is constructed on a large river in hilly areas to ensure sufficient water storage at height. The dam forms a large reservoir behind it. Control gate. The function of control gate is to control the water from the reservoir to flow through the penstock. When the control gate is fully open, maximum amount of water is released through the penstock. Penstock. A penstock is a huge steel pipe which carries water from the reservoir to the turbine. Potential energy of the water is converted into kinetic energy as it flows down through the penstock due to gravity. Water turbine. The turbine is mechanically coupled to an electric generator. Kinetic energy of the water drives the turbine and consequently the generator gets driven. Generator. A generator is mounted in the powerhouse and it is mechanically coupled to the turbine shaft. When the turbine blades are rotated, it drives the generator and the electricity is generated, which is then stepped up with the help of a transformer for the transmission purpose.
A hydropower plant converts the force of moving water into electricity. Hydropower is the leading renewable energy worldwide. Hydroelectric facilities fall into three main categories based on the head of the falling water: height head, median head, and run-off river. Dams thin the flow of water course, the retaining large volume of water in reservoir. When electricity is needed, gate in the dam open, allowing water to flow down giant pipe called penstock. The long penstock brings the relief water to the power station below the dam. To preserve the river ecosystem, the flow of water running in the natural riverbed between the dam and the power station is kept above a defined minimum. The force of the water exciting the penstock within the power station turns a turbine. The spinning turbine drives a generator. Use the interaction between the magnet of the moving rotor and the copper winding of the stationary stator to produce an electric current. A transformer boosts the current voltage to between 225,000 and 4,000 volts, thereby facilitating transmission over the grid high voltage power line. Water leaving the turbine returns to the riverbed via the terrace. All elements of the hydroelectric facility are periodically monitored and inspected. Most facilities are automated and are able to generate electricity rapidly to meet peak in demand. Hydropower production is not a source of greenhouse gas. So, the conclusion working principle of the hydropower plant is the electric produced from the movement of the water to spin turbine that generate kinetic energy, which is converted to electricity through generator and sent to the power grid.